Okay, hi everyone. Here we go. We're going to work on imaginary numbers. We're going to call them as complex conjugates today. So complex numbers. Here we go. Come on, pen. So complex numbers. And we're going to lead us to say complex conjugates. That's a J. Okay, complex conjugates. That's where it's going to lead us into. Now, we talk about complex numbers. Where do we get them from? It's, let's say, if I have x squared is equal to -4. Now, will x squared ever equal to -4? Now, what does that mean, x squared equals -4? If I said y is equal to x squared, let's start off that way instead. And y is -4. Is that ever going to be true? Now, if I draw you a graph of y is equal to x squared, here's the table of the graph. If I say x and y, for y is equal to x squared, if I plug in 0, 1, 2, 0 squared is 0, 1 squared is 1, 2 squared is 4. Let's plug in -1 and -2. We're looking at +1 and +4. So when we look at the graph looks like a parabola we talked about before, and we've drawn plenty of parabolas already. One space over, one space up, two spaces over, four spaces up. Will this graph ever become y is -4? -1, 2, 3, 4. Will this graph ever reach down to -4? And you can see that there are no answers here. Whoops. That's negative. What did I write that? -1, 2, 3, 4. Will this graph ever reach down to -4? Answer is no. It doesn't exist down there. Now, it doesn't exist down there means there's no solution. There is no real solution here. No real solution. It's like you guys can dream to be millionaires all you want, but I'm not a millionaire. I'll never become a millionaire. So it's almost like it's like this lofty dream. But math, remember we mentioned before for imaginary numbers, doesn't stop there. And if I go ahead and solve this algebraically, x squared equals to -4, we would take the square root of both sides. And we said we come up with our plus and minus version, and the square root of a negative number leaves us what we call a square root of -1 is I. So that's what we always swap out -1 for. We swap out square root of -1 for I instead. So it's going to be plus and minus I square root of 4. Now that we remove the imaginary aspect of it, the negative part, the part that was we were on disagreement for, x is equal to plus and minus 2i. Because the square root of 4 now becomes 2. We were not able to take a square root of the -4, but once I got rid of the negative, then we were able to take the square root. Okay. So the idea here is that there wasn't a real number that worked. We couldn't plug in 2 squared to become -4. We couldn't plug in -2 squared to become -4. Because 2 squared is 4, and -2 squared is also 4, and that isn't -4. Right? It doesn't work. But if I plugged in -2 squared, oh sorry, not 2, sorry, someone just came in. If I plug in 2i squared, let's see what happens here. 2i times 2i is 4i squared. I squared is -1, and that's -4. Remember, I squared is -1 by definition. Okay, so go ahead and catch up on the notes here. I'm letting some people in the class. Okay. Now, this was like the easiest case, right? Now, we had other problems when we used the quadratic formula, and when the quadratic formula failed us. So let's go ahead and look at our problem with the quadratic formula. X squared plus, let's say 3x plus 4. Okay. Y is equal to x squared plus 3x plus 4. And we're going to try and make this go to 0. Will this ever become 0? X squared plus 3x plus 4. And you're saying, maybe, right? Let's try factoring this first. Remember whenever we have a x squared, we want to try factoring it. Two numbers that make a 4 are 1 and 4 and 2 and 2. But do any of these add up to become 3? Nope. So first thing we realize this isn't factorable. Since it's not factorable, we are going to use the quadratic formula to solve it. We can always complete the square also. I think quadratic formula is what we're practicing right now. So quadratic formula is x equals negative b plus and minus square root of b squared minus 4ac all over 2a, where a is 1, b is 3, and c is 4. Now, the way I've been trying to teach you guys to do quadratic formula is to do it as fast as you can. So I'm going to go ahead and give you guys just 30 seconds and see if you guys, for you guys to set up and simplify. You don't need to solve, to set up and simplify. So multiply the a, b's, and c's and all these stuff together. So go ahead and do that for me real quick while I let some more people in. Okay. X equals to negative b plus and minus square root of b squared minus 4ac. 4 times 1 times 4 is negative 16 all over 2a, which is just 2. So one thing I wanted you guys to get used to is doing quadratic formula by multiplying it in your head. If not, you can do it on the side. You can say 4 times a times c on the side, so you can come back and write it in. And this would save you time, right? If you don't have to write it, it does save you time. And this is still showing work. I'm not going to minus points because you did some steps in your head. And these are obvious steps, okay? They're not just made up stuff. Oh, negative. Why did you not write negative 5? Oh, yeah, okay. So someone asked me, why don't I just write negative 5 here? You can. And sometimes what I'll do is I'll show you guys, you might write this, 9 minus 16. And it's not negative 5, it's negative 7. So you can jump to the next step. You can say x equals to negative 3 plus or minus square root of negative 7 over 2. You could jump from here to here, but please, to show work, on the side, just write 9 minus 16 on the side. And that shows me that, hey, you're doing the work. And that doesn't take that much time. If you want to replace this with this, fine, but on the side, just write 9 minus 16. And it helps your brain not have to overly think too much. Okay, now we're stuck with this problem here. Our answer is, can I take a square root of negative 7? Nope. So we're going to rewrite this as an imaginary answer, 3 plus minus I square root of 7 over 2. Now, this is what we call a complex number because there's imaginary and real aspects to it. Let me show you, let's talk about the real part. The real part is negative 3 over 2. This is a real number. Plus and minus I square root of 7 over 2. And this is the imaginary part. And this is what we call a complex number. A complex number is a number that has both real, and imaginary parts to it. Could it just have complex? Could it just have imaginary? Yeah. You have a 0 as a real. Okay. So here is one thing I want you guys to notice. The last two problems here, when we had imaginary numbers, how many answers do we come up with? So look at this first one here. How many answers do we come up with when we have imaginary numbers? Positive 2i and negative 2i. Down here, this is a little bit messy, but it's negative 3 over 2 plus I square root of 7 over 2, as well as negative 3 over 2 minus I square root of 7 over 2. So here is one thing that we want to realize, is that we always have two imaginary numbers. We always have two imaginary numbers. Always have two imaginary numbers. So if I tell you this, let's look at this question here. X squared plus 64 is equal to 0. Is this possible? Looking at x squared plus 64 without doing any work, here, I want you guys to think if it's possible. Now, I want you guys to realize this. First thing I want you guys to come up with is x squared. X squared, to cancel out a plus, right? To cancel out a plus 64, don't we need a negative 64 to make this go to 0? To cancel out a plus 64, we need a negative 64, right? But will x squared ever become negative 64? Can x squared ever become negative 64? Well, doesn't a square, that's right, if I put negative 8 squared or positive 8 squared, oops, positive 8 squared. Negative 8 squared is positive 64, and 8 squared is 64. Turns out, no matter how we deal with it, you cannot, whenever you square something, it always becomes positive. And that is a general rule. Whenever you square something, and it's a trick that we're going to take all the way to calculus, whenever you square something, it's always going to become positive. So will a positive number plus a positive number ever cancel out to become 0? No. So automatically, I'm looking here, I'm saying, man, this is a failure already. This is going to be an imaginary number. So go ahead. Let's go ahead and solve it like we would. X squared equals to, I want minus 64 to both sides. Negative 64. X equals to plus and minus the square root of negative 64. And x is equal to plus and minus I. Let's rewrite this over here. It's going to be plus and minus I square root of 64. Now I can take a square root of 64. And we're going to call this, instead of I, we're going to call this, we're going to write our regular number 8 I for this problem. So what are the answers for this? The two possible answers are 8I and negative 8I. Or we could say this is 8I and negative 8I. Now, here is something I want to say. What if I told you, if 8I is a root of f of x equals to x squared plus 64. Let's say if I gave you this question is, okay, if 8I is a root of f of x squared plus 64, what, sorry, are the roots of x squared plus 64? Okay. What are the roots of x squared plus 64? Well, I want to ask you first, bring up this point. If this is an x squared problem, how many roots are we expected to have? If you remember from before, if it's x squared, we are expected to have 2 roots. We're expected to have 2 roots. Okay. Cool thing is that, didn't I just tell you one of the roots? I told you one of the roots is 8I. So what do you think the other root's going to be? If one root is 8I, what do you think the other root's going to be? Negative 8I. Without any work, we can say complex conjugates, you must have a positive version and a negative version. And let me be specific. This is going to be, the negative doesn't go anywhere. It always goes next to the imaginary number. You have a plus version and a minus version. So without me doing any work, on IXL, they're going to give you one of the roots. Okay. Now, here is one of the problems. It says, here's another example. if I gave you the f of x is equal to x squared minus 268x plus 23,285, okay? And I say find the roots. Find the roots. Well, we could do quadratic formula. X equals to negative b dot 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 dot. And you could cry when you're looking at these numbers because they're gigantic, right? But the IXL is going to also tell you this. One root is 134 plus 73i. So they're going to tell you one of the roots. Now, here are some, so let's go ahead and just tell you the answer. If I told you that this is one of the roots, what is the second root? The second root is automatically 134 minus 73i. We're done. Now, here is where kids forget and kids mess up. Remember how we said whenever x equals to negative b plus and minus square root all over 2a, who does the plus and minus go to? Does it go to the front b number or does it go to the square root? And that's the thing, it always goes to the square root. And that's where the imaginary number comes from. Okay, that's where the imaginary number comes from. So that's where the plus and minus goes. This answer is not right. This is the wrong answer, okay? If I gave you negative 134 minus 73i. If you wrote this would be wrong. You gave me too many negatives. If you looked at all our answers right now, as we talked about this, we said we come up with two answers. So our first answer here was plus and minus 2i. Okay, so the plus and minus went to the imaginary. Our answer here, the plus and minus went to the imaginary, not the number in front. Our plus and minus went to the imaginary. And now if I give you part of the answer, 134 plus 73i, the plus and minus go to the imaginary, not to that front answer. Let me give you another one. If I said f of x is x squared minus 172x plus 12437. Okay, this is a huge number, right? And you could do quadratic formula on this. And quadratic formula would totally work. And here's one of the roots. Root at 86 minus 71i. Okay, so if I told you one of the roots is 86 minus 71i, what is the second root? The root is 86 plus 71i. Please notice the plus and minus goes to the imaginary, not that front number. Okay, let's do one more. F of x equals to x squared plus 328x plus 4585. Okay, here's the root. Negative 164 minus 117i. Go ahead and tell me what are the two roots. Go ahead and tell me what are the two roots. Remember, roots are my zeros, right? Okay, so you're going to take the one you wrote already, 164, minus 117i. And the second one is going to be negative 164 plus 117i. Okay, so remember the plus and minus goes to the I, not the term in the front. So these complex numbers are always made of this a plus and minus b, right? We have our real number in the front, and we have our imaginary number in the back. And the plus and minus always to the back part. Okay, I think that's the easiest part of this IXL part. Now the next part that's going to be a little tricky is I'm going to go backwards and say, hey, write the polynomial. And we were practicing this for the given roots. So we were practicing this on the IXL. And if I gave you x is equal to plus and minus 2, that's it. These are my roots, plus and minus 2. You would then go back and write the factors, x plus 2 and x minus 2. Where we would say this is a minus 2, that was my root, negative 2. This will be a positive 2, that's the roots, right? That's where my plus and 2, plus and minus 2 came from. And then you would have to manually multiply these together. X times x is x squared. X times 2 is negative 2x. 2x times x is 2x. 2 times negative 2 is negative 4, right? X times x times negative 2, 2x, and then negative 4. And then x squared plus, x squared minus 4, because these two cancel out. Okay, and that's our original polynomial. Well, what if this was imaginary? Okay, if this was an imaginary problem, I'm going to change that 2i to a x is equal to plus and minus 2i now. Okay, so my roots are going to be 2i and negative 2i. Okay, so here's our skill. We go back and we do exactly what we did up here, on top here. We do a parentheses, we say x minus, and let's go ahead and plug it in. 2i and negative 2i. What happens to the negative? This becomes a x plus 2i. And now here is the tough part. The tough part is just multiplying it together. X times x times 2i. Then we're going to multiply negative 2i times x, and then negative 2i times 2i. So x squared plus 2, I'm going to say ix, minus 2ix minus 4i squared. And this is where kids get confused. But here's my point. Just take your time. I'm multiplying one term by one term. 2 times, the last part, negative 2 times 2 is negative 4, and I times I is I squared. We have one extra step because it's imaginary. First, notice the middle terms always cancel out. Okay, these middle terms always cancel out for us, because we don't want any more imaginary. And please also focus on this last point here. So we have x squared. I squared is negative 1. So it's negative 4 times negative 1 becomes a positive 4. And that's our function. This is our original polynomial that has the imaginary roots with roots of 2i and negative 2i. I want you to re-examine x squared plus 4. Can x squared plus 4 ever actually equal 0? This is a positive. X squared will always be positive. Will positive plus a positive ever become 0? Nope. Okay, now let's get more into complicated roots. Now, if I told you x was equal to 3 plus I. Okay, 3 plus I. what would the conjugate be? Okay, the idea of a conjugate, it's the pair. What would be the corresponding pair to x plus I? Okay, and this is something that you have to come up with. If I told you one of the answers is 3 plus I, what would the conjugate, what would the pair be? Okay, what would the conjugate be? And the word conjugate for us, we're going to use synonymous with the word pair. What would the pair be? Okay, so the conjugate. Specifically, these conjugates are talking about imaginary numbers. Because if I have 3 plus I, the conjugate would be 3 minus I. Okay, so you guys ever heard the word conjugate, like conjoined twins, like conjoined? This is like the joined pair. Okay, so this is what we're gonna do. We're gonna do exactly what we did before. Hey, look, we wrote the roots, then we're gonna write the factors. Let's write the factors. It's gonna be x minus. I'm gonna give myself some space. The first pair is gonna be 3 plus I, and then second conjugate is 3 minus I. So take a look here. First things first, they gave us 1. We had to come up with a second one ourselves. Once we came up with the second one, I then wrote the two factors. I wrote them in factored form. Now, you have to make sure, take a look here, this is a mistake that oftentimes kids make. They write it as x minus 3 plus I, messing up on the sign, meaning they don't write their parentheses, so they don't flip it. But really, the negative has to flip both of those. X minus 3 minus I, x minus 3 plus I. Okay, so be careful about this. This is a common mistake. Negative times a positive is a negative, and negative times a negative is a positive. Now, this next part here is really where the work happens. I have 1, 2, 3 terms in each. Okay, I have 1, 2, 3. That means when I multiply 3 times 3, I'm going to end up with 9 different values, okay? 9 different sets. That's a lot of stuff to come up with. So what I'm going to do is, to try to keep this in order, I'm going to multiply x, then x, and then x. After I'm done with x, then I'm going to do a 3, 3, 3. And then I'm going to do I. Okay, I'm going to go in that order. This is the distributive property. So let's go with x first. X times x is x squared minus 3x plus ix. Is everyone okay with what I did here? I took x first and multiplied by 1, 2, 3 terms in the back. And you can see none of these are like terms. Okay, who's next? Negative 3. So we multiply negative 3 times x, negative 3x. 3 times 3 is 9, positive 9. I'm going to give myself a space here because these are not like terms, And negative 3 times I is minus 3i. Let me write that a little nicer. Minus 3i. Okay, so we finished the negative 3. Now it's negative i's turn. Negative I times x is negative ix. But take a look here. We have negative ix. So we're combining those like terms. Negative I times 3 is negative positive 3i. Take a look here. Everyone take a look. Oh my gosh, these pairs are going to cancel out. The last one, negative I times I is negative I squared. Okay, I have a question. I don't understand how you put everything in the parentheses. Okay, let me go ahead and do that one more time before we finish the problem. If I write factors are always x minus blah, okay, that's how we come up with our factors, given the roots. And this is my root here. So I write x minus, since this isn't just one term, this is a set of things, I write parentheses first. And that's where the blah goes. What's the blah here? 3 plus I. And then I'm going to distribute x minus 3 minus I. And that's how we end up with our first term. We do the same thing for my second term. X minus blah, which is 3 minus I. We multiply it out, the negative. X minus 3 plus I. And that's how we end up with that second term. So whenever we write a flat factor, it's always x minus blah, whatever that root is. But in this case, the root wasn't just one simple number, it was two numbers. So we have to write that parentheses to remember to distribute that negative sign. Okay, and I remember this every year when I'm teaching this. So please, everyone take a look here. I'm going to save you guys some time. This I squared, we're going to save you guys some time, okay? So what is negative I squared? I squared is negative 1. Negative times negative is a positive 1, isn't it? So here's what I'm going to do. To save myself time, I'm going to say, isn't this just a positive 1? I'm going to write positive 1 there. So instead of leaving it as negative I squared, I'm just going to change that to a real number. Negative I squared is negative times negative 1, which is positive 1. And doesn't that nicely combine with the 9 here? So I'm giving us an extra step right now, but it will save us time in the long run. So let's combine what we have. We have x squared. We have negative 6x. And we have, negative I squared, no, negative ix plus ix, and negative 3i plus i. Those all cancel out. Perfect. And we're left with plus 10. I'm sorry, 9 plus 1 is 10. It turns out this polynomial here has the roots of 3 plus I and 3 minus I. Now, you might not believe me, so I'm going to go ahead and do quadratic formula here. X equals to negative b becomes a 6 plus and minus square root of b squared, which is 36, because 6 times 6, minus 4ac, 4 times 1 times 10 is 40. Right? Let me show you what I did. I said 6 squared minus 4ac. That's 36 minus 40, right? All over 2a, which is 1. Again, you guys can say, hey, isn't this 36 minus 40 is negative 4? And just write negative 4 here instead. 6 plus and minus square root of negative 4 over 2. 6 plus and minus, okay, what's the square root of negative 4? Well, that's I, and square root of 4 is 2, all over 2. We can divide everyone by 2 now. 3 plus and minus I. And guess what? That's my original answer. So yes, it is a lot of work, sure. But it really isn't hard work. And the more you practice it, the faster you can get this done. So we're going to do one more example of this. Okay. So let's do one more example of this. But this time, let's throw in another number. Let's throw in a real number. So let's say the roots are this. The roots are, sorry, let's do it this way. X equals to, let's say 2, then 3i. Are these all my roots? If I say 2 and 3i. Can you guys type in the chat what I'm missing a root. What's the root I'm missing? Imaginary numbers always come in imaginary pairs. The conjugate. What's a conjugate of 3i? Okay, I'm getting some answers. Thank you. Then one we're missing is negative 3i. Perfect. Now, on the side note, if I said the same type of problem and I wrote 2 and 1 plus 3i, what would the conjugate be for this one? 1 plus 3i? This would be 1 minus 3i. Okay? So this is just another example. So remember, the conjugate pairs, the plus and minus only goes to the imaginary number. Okay? So let's work on this easy one on the left. Not easy, but you know. So our factors are going to be x minus 2, x minus 3i, and x minus negative 3i. Folks, what's a negative negative? You could have just skipped it and you could have just told me it was going to be a plus 3i, okay? because this is the easy one. But on the right side here, we have to write x minus 1 plus 3i and x minus parentheses 1 minus 3i. So just be aware of how they're treated. We're always saying x minus for a factor. So this would be x minus 2. And we have x minus 1 minus 3i and x minus 1 plus 3i. And now we just have to multiply everything together. Do not multiply the real and the imaginary. Do not do that first. Always multiply the imaginaries together, because we know stuff is going to cancel out. We know stuff is going to cancel out. So let's go and multiply this. X times x is x squared. X times, remember how we do FOIL? So x times x is x squared. X times 3 is plus 3ix. Moving on to negative 3i. Negative 3ix minus 9i squared. Okay, you'll see that the middle terms always cancel out. And we're ending up with, what is I squared? That's negative 1. Negative 1 and negative 9 is a positive 9. X squared plus 9. And do not forget, we still have our x minus 2 term in the front. Now we can multiply this together. X, and then negative 2, negative 2. So x cubed plus 9x minus 2x squared minus 18. You can rewrite this, x cubed minus 2x squared plus 9x minus 18. Okay. The one on the right is going to, of course, cost me more time, but I'm going to just do it quickly. Okay. Here we go. I'm going to multiply the x by x times negative 1, and x times 3. And I'm going to go through that for all three sets. So x squared minus x plus 3ix. Take a look. I just multiplied everyone by x. Now I'm going to multiply everyone by negative 1. Negative 1 times x is negative x. Negative 1 times negative 1 is positive 1. I'm going to write this on the side. Give it some space. And negative 1 times 3i is negative 3i. I'm almost done already. Negative 3i times x is negative 3ix. Negative 3i times 1 is going to be a positive 3i. And a negative 3i times a positive 3i is going to be negative 9i squared. But hey, remember what we're going to move that over. Negative 9i squared is going to be a positive 9. Because I times I is negative 1. And negative 1 times negative 9 is positive 9. All right, we're going to combine those together. We have an x minus 2 in front from before. And we have remaining x squared minus 2x plus 10. I'm going to go ahead and show you guys what happens to some of these terms. These guys here, take a look. Plus 3i minus 3i, gone. Minus 3i plus 3i, gone. And we had moved this guy over to become positive 9. Okay, so negative 1x is negative 2x. And 1 plus 9 is 10. Our last step here, we still have to multiply everything back together. Our binomial and trinomial. So let's just do it. Don't even grunt, don't even be annoyed, just do it. X cubed minus 2x squared plus 10x minus 2x squared plus 4x minus 20. X cubed minus 4x squared plus 14x minus 20. You're done. That took 10 seconds. All right, that literally took 10 seconds. Go back and watch the YouTube video, 10 seconds. So instead of complaining and griping and going, oh man, just do it. You'll be done before you're done complaining. Okay. All right. Okay, so that's the skill that we're going to be practicing. Make sure you do learn these skills. These are SAT skills. And these are skills that you'll eventually come back and be tested on. The idea is that it will give you roots They might not give you all your roots. Sometimes the conjugates, they'll give you only some of them, and you have to realize you have to come up with the rest of them yourself. And we can multiply these back to become a full polynomial, and that's sometimes what they're looking for, and that's what they're asking for in this homework. We're gonna go through like 3 different phases in this homework. So go ahead and practice that. We only have one IXL today. Okay, thank you.